Chapter 9, 9-07, the Sine Rule. The angles of a triangle are labelled with capital letters while the sides are labelled with lowercase letters. So we've got capital letters at the apex, right, the angles there, and then directly opposite we use the smaller case letter for the distance of the side, the length of the side. So the capital B angle, the opposite to that is a small b. Capital A is a small a. By convention, we use A to label the side opposite the angle A, B to label the side opposite angle B, and so on, as you can see in that diagram. There is a relationship between each angle in a triangle and its opposite side. The longest side is always opposite the largest angle. Okay? So this angle A looks bigger than B and looks bigger than C. So we're saying that that length must be longer than B or C. Okay? Because that's the largest angle, that's the longest side. The next smallest side is opposite to the next smallest angle, and so on. This relationship is called the sine rule. So there's a relationship between the angle and the opposite side. Summary. For any triangle ABC, A over sine A equals B over sine B equals C over sine C. The ratios of the sides in a triangle to the sine of their opposite angles are equal. That's a great diagram right there. And also, the reciprocal of all this is okay as well, which we'll see soon, that sine A over A equals sine B over B equals sine C over C. Now, this is the proof, and we've done this in class. Read through this again and make sure that you understand the relationship between all these letters, all this algebra here, and the diagram. The thing to keep in mind is we've broken up any triangle into two right-angled triangles, and they both have a common side, which is H. So that's now a right-angled triangle, and this is a right-angled triangle. And we took sine A, which is H on B, and we took sine of B, which is H on A. And so we have this common H, and then therefore H equals A sine B by just rearranging that and substituting back into this one for H, A sine B, and we have A on sine A equals B on sine B. But read through that, it's clearly written, and make sure you refer to the diagram. Okay, and by drawing the perpendicular from A to BC, it can be shown that B on sine B equals C on sine C, and we end up with this A on sine A equals B on sine B equals C on sine C. We have used trigonometry to solve problems that until now have involved only right-angled triangles. See, the bigger triangle here is not a right-angled triangle, the bigger one. It's only these two smaller ones that we've created a right angle. The sine rule allows us to apply trigonometry to any triangle. The sine rule can be used in problems involving two sides of a triangle and the two angles opposite them. Example 17, find y correct to one decimal place. Okay, we've got to find that length y. Now, using the sine rule, it's fairly straightforward. We have an angle here and we have the opposite length, so that's good. We have an angle here and we don't have the opposite length. So we can see there's a relationship between this angle and that length and that angle and its length on the opposite side. And we use the sine rule, and we've got A on sine A equals B on sine B. Okay, we just substitute those things in. We've got X, Y, and Z here, and we've got A and B. That's okay. So what we need to do now is to say that this is the right-hand side. 12 divided by the sine of 50 equals y, this is the left-hand side now, this side, y divided by the sine of 34. Okay, and we put the y over here on purpose, they did, so they can make it a bit easier to resolve. It's already on the left-hand side. We multiply both sides by the sine of 34, that removes it from here, and we've just multiplied this by sine of 34. Or if you know about cross-multiplying, we can just take what's down here. We only do this if there's one term here and one term here. So we've got sine of 34, and we just move it straight to the top over here, and we've got 12 sine of 34. And then we use the calculator, and we get to one decimal place 8.8 centimeters for y. And we look at it, and remember what they said with the rule, the bigger angle has the bigger, when you compare two angles, the angle that's larger of the two angles is going to have the longer side. So we're expecting y to be less than 12, and we did. It became 8.8 because 34 is less than 50. Okay, so now exercise 9-07 is on the sine rule. It's easy in maths when they tell you what rule to apply, and all of these here you apply the sine rule. Similarly, 3, 4, and 5, we know it's going to be using the sine rule. Now, in a normal test, you wouldn't know. You'd have to look at what information they give you and have to decide whether you should use the sine rule or not. More questions here, 6 and 7. Again, we know we're going to be using the sine rule. And bearings as well. So that's a lot of fun. And also 8 and 9, and these are common test type of questions here. We've got two positions there, and an object. Quite good questions they are.